Algebras, and welcome to your Chapter 5, Lesson 1, Day 2 notes. So we have already graphed our systems of linear equations, looking to see if there was an intersection point and what it was. Now what we're going to do is we're going to look at maybe some other functions that might be on the graph at the same time, and if they have intersection points or what that might look like. So systems don't have to just be lines, right? Systems don't have to just be two lines. They could also be, like, for example, number one, they could be a line and an absolute value. Okay, so how do I know that f of x is a line? Well, look at its equation. There's no exponents. There's no bars around my variable. There's no squared. There's no, x isn't in the exponent. There isn't a radical at all, right? There's not a square root symbol. So that's how I know that this is a linear function. Okay, that's how I know that this is a linear function. Versus g of x, I know that this is an absolute value function because it's got the absolute value, the straight up and down bars around my x. So I know based on looking at the equation what they are. And that's all from chapter 3 when we were talking about what's the difference in types of functions. Now, here's what we're going to do. We are going to graph the linear function. We're going to graph the absolute value function. And then we are going to determine when f of x equals g of x. And I'm going to show you how to do that. Okay, so let's start with the linear function. This is in y equals mx plus b form, because if it's in function notation form, it's in y equals mx plus b form because your y is we're stand-in for f of x, right? And vice versa. So mx plus b is this guy over here, this side. So what's the y-intercept? It's 2. What's the slope? It's 1. So that means I start on my y-axis at 2, because that's my y-intercept. And from here, I use my slope, the m value, the number in front of the x, to determine if I go up or down and left or right. So 1 over 1 is my slope. It's up 1, right 1. And because this is a system, and I don't know where the other thing is going to be on the graph, I'm going to graph all of my I'm going to plot all of my points. So I go back to the y-intercept. Well, the opposite of up 1 and right 1 is down 1 and left 1. And notice 2 negative moves actually give me a positive slope, right? Down is negative, left is negative, but making 2 negative moves gives me a positive slope, because negative divided by negative is positive. And that's what slope is. So I use my straight edge to graph my line, to actually draw my line, right? Then I put arrows at the end. I'm going to hold off on labeling because I don't know where the other thing goes yet. So now I look at the other thing and I say, oh, well, this is absolute value. And again, because of the bars around the x, absolute value had that general form that we learned in chapter 3, lesson 6, and chapter 4, lesson 8. And that general form says that the number in front of the absolute value bars determines its slope to the right-hand side of the vertex. And the number in here and the number out here determine the vertex. It's the opposite sign of what's in here and the correct sign of what's out here. So that tells me, just looking at it, that my vertex is 1, 0. Because it's the opposite sign of what's in here, so positive 1, and it's the correct sign of what's out here. Well, what's out here is just a plus 0. Nothing is there. So that's a 0 here. So that means my vertex for this absolute value graph will be right here at 1, 0. Now the slope is the a value that's in front of the absolute value bars. And that just tells me from here to go up 2 and right 1. And notice as I'm doing that, I actually run into this part right here. Now go back and you do the opposite on this end, and look, I actually run into it again. Now remember, the absolute value, these points that I've plotted, these get connected to the vertex with a straight edge. So I take my straight edge, hold it to these. Now that I know I've got both things on the graph, I can start labeling. So here's my g of x, right? I'm just going to turn this a little bit. So g of x equals 2 absolute value x minus 1. And f of x equals x plus 2. And now, notice I've got two intersection points. So red and blue makes purple. Circle and label. This point is 0, 1, 2. So 0, 2. This point is 1, 2, 3, 4, up 1, 2, 3, 4, 5, 6. So 4, 6. Okay, so that's step 2, where we determined the coordinates where the two functions are equal, where they intersect. Okay, so the coordinates of those were 0, 2, and 4, 6. Now, the last thing we want to do here is we want to state the values of x that solve f of x equals g of x. Now, notice all you do is you take the x values from your coordinates and you plug those in for x in the function notation. So it'll be f of 0 is equal to g of 0, and that's correct because the f function at 0 is right here, and the g function at 0 is right here. That's correct. That's one statement of equality in function notation form. Now, the second one is going to be f of 4 equals g of 4. Also correct, because here's my g function, and here's its coordinate where the x value is 4, and here's my, oh, sorry, that was my f function. Here's my g function, and here's its coordinate where the where the g value is 4, where the x value is 4, and there you are. They're the same. They have the same output. They're the same point. That's how we state this part. So see how the question we were asked here specifically says to state this? That's why I have to put my answer here like this. Okay? That's why I have to write it that way, because it specifically said f of x equals g of x. All right? I just want to show you on our graphing calculator here. So let me make this guy a little bit bigger. Oops, I grabbed the wrong guy. Make this guy a little bigger. Okay, let me plug these guys into y equals. So y equals x plus 2, and then arrow down. y2 is going to equal, and that's obviously my g function because it's red, right? So math, arrow right to number, ABS is absolute value. And then, oh, I need to put some here. My 2 goes first. Then I can do math, arrow right to number, and 1 for absolute value bars. Now I can do my x minus 1. So notice that's what's in the absolute value bars. So press graph to see them both, and that will, oh, match up. Look at that. Now, let's say that I didn't remember chapter 3, lesson 6, and chapter 4, lesson 8, and how to graph the absolute value without the equation, right? I could actually just go here, second and graph, and get the table of points for my absolute value. Because look, the red is my absolute value. Here's points on the absolute value graph. Here, let me show you around the vertex here. So here's the vertex in the middle here, 1, 0, which is exactly the vertex I have. And then I've got 0, 2, okay, 0, 2, up. And then I've got 2, 2, okay, 2, 2, right there. And then I've got 3, 4, 1, 2, 3, 1, 2, 3, 4, yup, right there. See that? So I don't need to have that general form of absolute value memorized. It was just easier, to be quite honest. That was just easier to know that and know where the vertex goes and go from there. But if this is easier for you, use the table from the graphing calculator to graph those points. That's fine. Whichever one is easier. I find knowing the equation to be easier. All right. So as I was doing that, I noticed a couple of other things. Look, as I was graphing that absolute value, I noticed that 0, 2 is the same for both my line and my absolute value. Well, yeah, it's the same point on both graphs. And then I noticed it for 4, 6. Yeah, it's the same point on both graphs. So actually, this helps me double check my answer and make sure I was doing things right. And I was. So there we go. Graphing calculator. Great, great help. Great help checking my answers, right? Right. Of course it is. All right, example 2. I'm going to help you. Well, let's do it over here. I'll just kind of scooch over. I'm going to help you by stating what types of function each are, getting the one line into y equals mx plus b form. Then I'm going to let you guys try to graph them and see what your intersection points are, and then we'll check together. Okay? So, given that 4y plus 2x equals 16 and y equals the absolute value of x minus 3 minus 2, graphically determine the solutions to the system. Solution slash S, like, right? It could be 1, it could be 2, is what they're kind of saying. Like, there might be 1, there might be more. Line. This is a linear function. Again, nothing fancy. Nothing fancy going on. No bars, no radicals, no exponents. That's a linear function. I mean, you read it absolute value when you see the 2 straight up and down lines around the x. So we know that this is an absolute value function. We know that, right? Because you read those 2 straight up and down lines, absolute value. So what I'm going to do is I'm going to take 4y plus 2x equals 16, and I'm going to get y equals mx plus b form with you. And then I'm going to let you guys graph. I'm going to graph on my own. We'll pause. We'll pause and let you do that. I'm going to graph on my own. I'm going to get the answers. Answers. I don't know yet. And then we're going to check together. So let's start by moving the 2x over by subtracting it, right? Because a positive 2x, the opposite is a negative 2x. So bring down my 4y equals negative 2x plus 16. Again, I prefer mx plus b. Now I've got this 4 in front of y, so I divide everything by that 4. I get y equals negative, 2 can evenly divide with 4, but it's numerator denominator, so let's just divide both by 2, right? So negative 2 divided by 2 is 1, so negative 1 on top, and 4 divided by 2 on the bottom is 2, so this is a negative 1/2 x, or a negative 1/2 slope. 16 evenly divides by 4, it leaves me a positive 4. So here, this is my slope is negative 1/2, or down 1, right 2. And my y-intercept is 4. Okay. So now, with the absolute value function, you can choose, do you want to do the vertex and slope? Or do you want to plug into your graphing calculator and look at the table? So that's going to be up to you which way you want to go with that. Okay. I know which way I'm going. We know already. This is when you want to pause. Stop what you're doing. Pause the video. Graph these. And let's see how many answers there are, how many intersection points there are. And then unpause and we'll check our answers together. Okay. So I'm going to do this too. You're going to do this on your own. Pause, do this on your own, and then we'll come back and check our answers. All right, here we go. All righty, there it is. So let's take a peek. Looks like I got my answers to be negative 6, 7, and 6, 1. Oops, went too far. All right, so let's look at my graph. Okay, so for graphing for the line, I used y equals mx plus b form. Got my y-intercept right here. Got my slope of down 1, right 2. And of course, the opposite of that is up 1 and left 2. So I had to go both directions because I knew I was going to hit the absolute value on both sides, right? So I went both directions, counting my points with my line. Then my absolute value, I went with the vertex, right? So 3, negative 2 is my vertex, right? Opposite sign of what's in here, correct sign of what's out here. And my slope is 1/1 because the number in front of the absolute value bars is 1. So let's just check our answer with the graphing calculator. I'm going to pull this out first to put into y equals mx plus b, right? So y equals and y1 and y2. Let me clear these guys out because that's not the graphs I want anymore. In y1, I want negative 1/2. Okay, so the negative is the little negative button here under 3. And then front parenthesis, 1 divided by 2, end parenthesis, times x, and then plus 4. So there's my line. Now arrow down, nothing in front of the absolute value bars this time, so I can go straight to math, arrow right to number, there we go. ABS is 1 right here, so 1 or enter gets my absolute value bars. And then I've got x minus 3 on the inside. See how this little right arrow is pointing? Well, if I go right arrow right here, I come out. There's my cursor, and I'll minus 2, negative 2, I should say, or minus 2. Yep, subtract 2 out here. And let's graph. Look at that. Let me pull back here. Looks just like my graph. Yep. Now look, I have a decent idea looking at my graph where my intersection points will be, right? So 1, 2, 3, 4, mid negatives over here and mid positives over here will be my intersection points. So second in graph gets me my tables. So right now I'm not seeing an intersection point on the negative side, but I am seeing the intersection point on the positive side. Now, if I were to graph my line from from my graphing calculator tables, would I graph these decimal values? No, I would graph the integer values and just connect them. And by connecting them with my straight edge, I am graphing these in-betweens. Now with the absolute value, look, I look for my vertex, which is 3, negative 2. So right there, right where I had it. Intersection point, 6, 1, 1, right? So the 1 is shared by the 2. So that's this guy. So now I got to go on the other end because I know there's another one up here. So I arrow up until I see a match. There's my matching y value, negative 6, 7. So I check myself. Okay? That's how we do this. So now, if I've got something like this, example 3, right, and example 4, I'm going to use my graphing calculator to help me answer this, right? If I don't have the graph to actually write out, look at, they're giving me a line and an absolute value. So I'm going to plug this stuff into my graphing calculator and determine it just like I did in those 2 problems where I was using it to check. Well, now I'm going to use it to do the problem. So if functions y equals negative the absolute value of x minus 2 plus 4 and 3y minus 3x equals negative 12 are graphed on the same set of axes, which statement is true about the solution to the system? This is a former Regents question. Okay. So absolute value. Actually, I've been doing absolute value in red, so I'll continue to. And linear. So the absolute value is fine. That's what I can type in that form. But the line, I'm going to need to get into y equals mx plus b form to be able to type it into my graphing calculator. Got to get that y alone. So let me write up here where I've got some blank space under algebra. So 3y minus 3x equals negative 12. So we want to get the y alone, so add this 3x to both sides. 3y equals 3x minus 12. Divide everything by 3. And we get y equals, well, 3 over 3 cancels out to 1. So same here. It's going to cancel out to a 1. I don't write the 1 in front of my x, but you're welcome to because it means the same thing as having an x. 1x equals x. And then here you got negative 12 divided by 3, right? So that would be a negative 4. Okay, so that's what I'm going to type in for my y1. This is what I'm going to type in for my y2. And let's see what they look like. Y equals, let's type this in for y1 because that's where my lines have been going. And I did that in blue, right? So y equals x minus 4. And then my absolute value 1, and I've been doing that in the red, so I'll keep it there. The negative under the 3 has to start your functions when they start that way. And then math, arrow right to number, ABS. So inside it's x minus 2. So x minus 2 on the inside, then arrow out for plus 4. And let's plus graph to see things. Whoa! Hey, that's kind of cool. Part of this line is parallel with part of the absolute value, but once the absolute value hits that vertex, it comes back down and it meets at 1 point. Now, I'm not really sure what this 1 point is, but my guess is 5, 1. It's my guess. And I just kind of took a, look at it and am guessing. So now let's press second and graph to see. And so far I see no intersection point, but I see I'm getting closer down here. So let's arrow down. I was right, 5, 1. So now that I know that, so let's see, 5, 1. So I know that 5, 1 is the intersection point. Let's read all those multiple choices. -2, 0, 4, 0, and 5, 1 are the solutions. No, only 5, 1. 0, 4 is the solution. Nope. The solution has to satisfy both. Yes, 4, 0 is on this line, but it also has to be on the absolute value. And if you look, 4, 0 is not on this absolute value function too. It's only on the line. So I'm assuming this one does the same, and it does. Look, -2, 0 is a solution to the system. Look, -2, 0, -2, 0 does satisfy the red absolute value, but it does not satisfy the blue line. So because of that, it cannot be an answer. The answer has to satisfy both, and that's where number 4 is the correct because it satisfies both. So number 4, choice 4. Okay? So using that as your basis, why don't you try example 4 on your own? Okay, so this is when you pause again, plug these two into your graphing calculator. Let's see what we get. Okay, plug these two into your graphing calculator. Let's see what you get. You got to pause, and we'll be right back. Okay, here it is. So the absolute value and the line meet in one spot. It looks like that one spot is 1, 2, 3, 4, 5 up 1, 2, 3, 4, 5, 6-ish. Well, that's why I got my tables. So second and graph can get me to my actual tables. So we think it's, I was so close, right? It's so tough to count on that grid because it doesn't have all the individuals, right? But 5, 7 is our intersection point, okay? There is not another intersection point. Now, in 5, 7, 5 is the X value and 7 is the Y value. So we read each of these statements, okay, and we make sure we have the right answer. Now, it says the solution to f of x equals g of x is -1. Well, the X value here is not -1, so that's not it. The solution to f of x equals g of x is 5. Well, that's what I have so far. So far this is right, but let's just read the rest just in case we have a question. The graphs intersect when y equals 5. No, y equals 7 when the graphs intersect. The graphs intersect when x equals -1. No, x equals 5 is when the graphs intersect. So yes, we had it, but we had to double check by reading the rest of the choices. So now you know what your homework will look like. It looks just like this stuff. Those are two separate types of ways the Regents has asked this other question of systems. Since we've already graphed absolute value in chapter 4 and we spent the rest of chapter 4 graphing lines, I think you'll be okay. But again, give it a shot. Let's see how it goes. And then we'll start moving on to doing this algebraically. That's my favorite part. Okay, guys. This has been chapter 5, lesson 1, day 2 notes. Good luck. Let me know if you need me. I shall be seeing you, algebras.